Testing. All right. Hello, everyone. This is the midterm review. What I'm going to do is be doing all the old tests that I printed out for you, and that these old tests hopefully help you out study for the midterm. The reason I make it a YouTube video is so you guys don't have to worry about. I know you guys have other tests throughout the week, and I want to make sure you guys don't feel pressure. Like, you can study on your own time whenever you're free, and hopefully this video helps you guys. Okay, so why don't I just get started? First things first, let's make sure that I'm just making sure the stream is working. All right. So let's start off with this. Is chapter 1. This is all the terms and stuff. Kind of a difficult chapter simply just because you're learning so many different words and such. All right. Point R lies on point G. So these are true or false questions. So point R lies on line G. Point R is here. Line G is this vertical line, so that's false. A, M, R, Z are coplanar. A, M, R, Z is coplanar. A, M, R, and Z are literally drawn on the same plane, which in this case is plane V. So this is true. A and Q are collinear. These are on the same line, so that's true. Collinear means the same line. Coplanar means the same plane. Two segments added together, 25 plus 12 is 37. These two, this says is a midpoint, so you know these two are equal. We also could tell by the congruent symbols. So x plus 2 is equal to 2x minus 3 plus 3 minus x, x equals 5. So x equals 5, and you plug it in, 7. You plug it in here, 5 minus 10 minus 3 is just 7. Next set. Find the distance and midpoint formula. So the distance formula is square root of y1, y1 minus y2 plus x1 minus x2. Doesn't matter if you put the x1 and 2 in front or back in this case. Both of these are separately squared. So let's plug in these numbers up here. So x1, y1, x2, y2. So let's plug in the numbers. 5 minus 0. And this is negative 4 minus 8. So negative 4 minus 8 is negative 12 squared plus 5 squared. That's all square root. Then that is going to be 144 plus 25, all square root, which is equal to 169 square root. And the square root of 169 is 13. So the answer for distance is 13. 13 units. I didn't give a unit, so whatever. It's 13 long, this line between these 2 points. And the midpoint is just the averages. So the averages is x1 plus x2 over 2, comma, y1 plus y2 over 2. The midpoint has to be a coordinate point. So x1, again, is 5 plus 0 over 2. And then the other one is 8 plus negative 4. Doesn't matter if I switch up y1 or y2 in this case, over 2. That's going to give me 5 over 2, which is 2.5. And the other one is 4 over 2, which is 2. So your point is 2.5 over 2, comma 2, I'm sorry. Over here, find the diagram of the indicated angle. So J and K. So J starts here at the 0 mark of the protractor, N, and then K is over here. So K is going to be at the, looks like the 35 mark. So you do 35 minus 0. K is at 35. J is at 0. So 35 minus 0, that angle is 35 degrees, okay? Let me see if I can zoom in so you actually can see a little better. All right. Next one, K and M. K and M. M over here, you could say is 180. And then over here is again 35. So it's 180 degrees minus 35. You take the biggest number and subtract it because you don't want a negative angle. This ends up being 145 degrees. So this is 145 degrees. And then KNL. So KNL, this is at 35. This is at 90. 90 minus 35 equals 55 degrees. So 55 degrees is for that one. Next one, use the information on the diagram to find the value of x. BD bisects ABC. So BD bisects AB. So if it bisects, that means we know this has to equal that. So it's 30 equals x plus 25 minus 25 on both sides. X equals 5. Over here, QRT equals 95. Find x. So you know the whole angle QRT is 95. So it's 12x plus 5 plus 6x, so the two pieces of the angle, equals 95. And because of that, we could combine like terms. So that's 18x plus 5 equals 95. Subtract the 5, subtract the 5. 18x equals 90 divided by 18 divided by 18. X equals 5. So, or x equals, 5. And you could plug that in to check if it adds up to 95. Next one, use the diagram to tell if they're vertical, linear, or neither. So A, 1 and 2, those share the same baseline. They have opposite rays. So that's a linear pair. Again, this should look back at it and seem easy because we use these terms all the time in all our later on. 2 and 5. So 2 and 5, they have two opposite rays. So two opposite rays. So because of that, that's vertical. And then 1 and 4, 1 and 4. So this is a bigger one. So this shares opposite ray, but they don't share a side, so they're not linear, and they don't share two opposite rays. So because of that, it's neither or none. Doesn't matter which answer you put. So it's neither or none. Or none of the above, I guess, would be, if it was a multiple choice, that's how it would look like. All right, next one. Number 9. Number 1 is complemented to number 2, and number 2 is 17. Complement, you got to know, means 90 degrees. So 90 minus 17, that's going to be 80, 73. So 73 degrees, okay? So angle 1 is 73 degrees. Angle 3 is supplement. A supplement is 180. So it should say supplementary, actually. Oh, no, is a supplement. That's fine. Of angle 4 is 36 degrees. So 180 minus 36 is 144. So 144 degrees is your answer for this one. That's angle 4 in this question. Number 11, the length of two sides of a regular hexagon. When you hear the word regular, you know all the sides are equal. So you know 4x minus 7 should equal 2x plus 11 minus 2x minus 2x. And just a quick algebra reminder, I always like to move the smaller x value and move the other, since I'm moving this one here, I move the other one the other way. So plus 7, I have 2x equals 18 divided by 2 on both sides, x equals 9. So x equals 9. Over here, tell the figure is a polygon. If it's a polygon, tell me it's converse or convex. This doesn't have a closed place, because since that's not closed, that's not a polygon. So no polygon, or not polygon, or something like that. Here, all the angles point to the outside of the shape. Because of that, it's convex. And here, the angle on the far right over here is pointing into the shape. So that's going to be a concave. Next page. Multiple choice. So these are the things you should be expecting in your midterm. All right, which is not drawn? AE, that's drawn. BD, that's drawn. AC, that's drawn. EC, that's drawn. FD, not drawn. FD is your answer here. Which statement about the figure is true? Lines X and Y intersect at point A. No, they intersect at point E. So that's not true. A, B, and C are collinear. A, B, and C are not all on the same straight line, so they're not collinear. EC and ED are opposite rays. EC goes this way. ED goes this way. This one's true. Now, I just want to talk about D. AE is another name for AB. Notice, look at the top symbols. That's line segment. So AE is only this space here, while AB is the whole space here. So because of that, they are not the same. So D is not an answer. What's the line of ST? You literally could count 1, 2, 3, 4, 5, 6, or do 4 minus -2. That would also give you 6. Count the gaps. Do not count the tick marks. If you count the tick marks in between, you'll get 5, which is wrong. Over here, if WX equals X is congruent to XY, what is the length of WZ? So WX is congruent to XY. So WX is congruent to XY, so this is also 3. WZ is the whole line, 7 plus 3, that is 10. Over here, name the correct name for the obtuse angle. So the obtuse angle is this bigger angle, EDG. These are two smaller angles. They're too small to be obtuse. So EDG is B here. Let's say you looked at it and you said GDE and you didn't see the answers. You got to remember, you could also flip it from EDG. What's the correct classification for this figure? Well, all the angles and all the sides are equal, so it's regular, but that's not really the question. So it's how many sides it has. 1, 2, 3, 4, 5, 6. There's 6 sides. That is a hexagon. Oh, we're on chapter 2 already. So chapter 2, let's continue. What is the property illustrated? G equals H, so H equals G. That's reverse. Like a symmetrical face, your left is the right is the left. They're not exactly the same, but they look the same when you flip them back and forth. So this is a symmetric. Over here, AB is congruent or equal to CD, and CD is equal to AB. Also symmetric. Number 3, this is the reflexive property. So if Y is a real number, so you got to show the reflexive property, then Y equals Y. That's what you want to show. If I said 3, it's 3 equals 3. It is reflexive. If it's line AB, AB is equal to line AB. Subtraction property of equality. If 3 equals 4, then the angle 3 minus 10 should equal angle 4 minus 10. The correct thing should have a measurement here. Number 5, use the following figure to find both x and y. So these two are vertical angles. If they're vertical angles, you can set them equal to each other. So for the x, you do 9x plus 1 equals 13x minus 51. Again, move the smallest x over, so minus 9x, minus 9x. Move the biggest 50 or then you leave the other one, you move it over. 51, 51. This is 4x, and then this should be 52. Divided by 4, divided by 4. X should equal 13. So x equals 13. We'll see the next one. Y, these are also vertical angles. So 2y plus 15 equals 4y minus 2. Distribute the 2 to everything. 2y plus 30 equals 4y minus 2. This is still the smaller y. This is still the smallest y. So minus 2y minus 2y plus 2 plus 2. 32 equals 2y, and then divided by 2 on both sides. Y should equal 16. Okay? Let's continue. Algebraic proof. This is just straight algebra, and then just explain your steps. So we could start with the first part, which is literally what we have in the beginning. 2x minus 1 equals 18x plus 6. So that's given. All right, next one. We're going to distribute the 10 to both of these. So it's 20x minus 10 equals 18x plus 6. That's distributive property. Next one. I'm going to move the x's over first. I always like moving the x's over. So minus 18x minus 18x. So that's 2x minus 10 equals 6. That is subtraction property because I subtracted 18x on both sides. Then plus 10 plus 10. So I'm adding 10 to both sides. So that's 2x equals 16. That's addition property because I'm adding to both sides. divided by 2, x equals 8. X equals 8 is the final answer. How did I get that? I divided on both sides, so that's division property. Next one, some actual proofs, okay? Again, there's no actual proofs on the test, but we do need to know the terms. So first, let's start with the givens. Then here, we turn it from talking about the congruence to the measurements. So that's definition of congruence. Because I know that if something's congruent, I know the measurements are congruent, or the measurements are the same. Okay, I'm going to try to move it over so you can see more. Okay, next one. Since KL equals LN and LM equals LN, they equal the same thing, so this is transitive property. And then the last one, L is the midpoint of KM. Because these two pieces are the same, and look at the picture, L is in between this. So we know since they're physically in the middle, it must be exactly in the middle. So we know that because we know the definition of midpoint. Next one, RS is 1/2 of RT. Given that, so that's given, we're going to prove this is a midpoint. So 2RS equals RT. So what he did is multiply 2 on both sides. So this multiplication property. So we multiplied both sides, right? So times it by 2, that cancels out. Times it by 2, cancels out. This one, RS plus ST equals RT. This part of the line plus this part of the line equals the whole line. So that's going to be segment addition postulate. Segment addition postulate. Now, 2RS equals RT. Since they both equal RT, we could substitute, or because they equal the same exact thing, we're going to say it's a transitive property. Again, these questions are multiple choice, so if I said substitution, you pick substitution. If I said transitive, you click transitive, okay? I won't do a trick and have them both at the same time. RS equals ST, so we're going to subtract RS on both sides, so that's subtraction property. And then the last one, S is the midpoint. We know these are equal size. Since we know these are equal size, that's definition of midpoint. Okay, let's continue. Some more multiple choice. It's like I've been preparing you. If A is 123, what's the measurement of a supplement? Remember, supplement's 180 degrees. So 180 minus 123. That should be 57. Hey, that's answer B. When two lines intersect, what is the point, their point of intersection? Wow, I really gave it free here. If two lines intersect, they only could intersect at exactly a point, so your answer is a point. I made it too easy there. I didn't even realize. Which statement is not a point line postulate? I guess that makes up for this question. So this is a really tricky question because all these statements are true. But A is talking about the definition of the word coplanar. All these are postulates. We have to state these in order to do all our geometry. But this over here is strictly a fact. Number 13. What is the least number of collinear points defined in the plane? So the least number of non-collinear points. So what's the smallest possible to make a plane? 2 only makes a line, while 3 makes a unique plane. So that's 3. The answer is 3. Over here, the only one you can say for a fact using these tick marks is that LB is congruent to BK. So since you know that, LK must be getting cut in half. So this one is C. This is actually kind of reminiscent to the last proofs on the last test, actually. Or 2 tests ago, at least. I think it's a test on the 24th, if it was on. The last test of this packet, at least. All right. Use this diagram for number 15 to 17. So it was, let me just show it again. 1, 2, 3, 4 in a clockwise way, starting with 1 on the left. If 2 is 128, then what is 4? 2 and 4 are vertical angles, so it should also be 128. If angle 1 is 74, what is angle 2? Angle 1 and 2 are linear pairs. Because they're linear pairs, they're supplementary. Because they're supplementary is 180 minus 72, or 74, oops, is 106. So 106 is my answer. What is the relationship between angle 1 and angle 3? They share two opposite rays, so they're vertical angles. Vertical angles probably are here, yes. They're not complementary. They don't necessarily add up to 90. They're not supplementary. They don't necessarily add up to 180. They are straight angles. That are not true. Straight angles are one angle that adds up to 180. We're already on chapter 3, which is really beneficial. Chapter 3. If two lines are not intersecting, then they're always parallel. No, because they also could be skewed. If you don't remember what skewed is, it's like two lines, one's here and one's going this way, but it's kind of like I didn't show out here, but one's like 3D, so it's like kind of like one's going towards the camera, like I'm doing right now, and one's going this way. The one going towards the camera and one going this way don't hit each other, but they're not on the same plane. The one going straight up is this vertical plane here, while the one going forward along the paper is the paper plane. So there are two different planes there. Anyway, that's the definition of skewed. The question was, if they're not intersecting, they must be parallel. That's not true. That's false. All right. If there is a right angle, then two lines forming the angle always are perpendicular. If it's a right angle, then the two lines forming the angles are perpendicular. So if it's a right angle here, it has to be perpendicular. That's the definition, so that's true. Consecutive angles are always congruent. Consecutive angles, when we're talking about transversals, consecutive angles are always congruent. So does this angle and consecutive. So it's this angle actually and this angle. Let me draw it a little bigger. So this angle and this angle, they're not necessarily always congruent, only if they were both perpendicular, so that's false. If two lines are parallel, they're never coplanar. Parallel, by definition, is on the same plane. So this is, if two lines are parallel, they're never coplanar. They're actually always coplanar, so that's false. They're always coplanar, by definition of the word parallel. Okay, next one. We're going to use this picture over here to classify the relationships following these terms. Number 5, K and C. So K is here and C is here. Opposite. So remember, when you take these, you cover up the one that you don't using, the non-transversal, and the one that's the transversal is the line that touches both angles. So it's this line over here, angle P on the side. So this is the transversal. They're on the outside of the transversal, or these two parallel lines, or not parallel, but two lines, and they're equal to each other. So that is K equals C. So they're opposite, alternate exterior. So alternate exterior. Next one, S and E, S and E, S, E. So S, E over there, they're in the same position on top left. Same position on top left, so that's corresponding. Next one, E and D. E and D, so that is the one I already have circled, plus this one here. So this is going to be inside, but they're on the opposite sides of the transversal, so that's alternate interior. L and K, so L and K. Here, they're on the same actual angle, or the same crisscross, so they're just connected to each other. So that's straight vertical angles. And H and U. H and U on the same, H and U, let me just circle that, is on the same side of the transversal, so on the bottom side, and they're both between, so that's consecutive interior. So consecutive interior. All right. Assuming that these two are parallel, follow these statements. If B is 32, so we're still using this question, is B is 32 here, and then G must be, where's G? G is over here. They're alternate exterior. Alternate exteriors are equal, so that's 32 also. If C is 74, so C is 74, so this one's 74, then F, which is alternate interior, I think I should have said the last one's alternate exterior, I hope I did. These are alternate interior, they're also equal, so that's 74. Then the last one, 12, if E is 53, so E is 53, and C is 3x minus 2, E and C are consecutive interior. Consecutive interior when parallel add up to 180. So 3x minus 2 plus 53 equals 180. Combine like terms, 3x plus 53, because negative 2 plus 55 is 53, equals 180. 3x equals, subtract 53 on both sides. So 3x equals 127 divided by 3 divided by 3. X equals 49. 49, 40, not 49. Uh, 127 divided by 3 should be it's not 49. It is 43.3 repeating. Unless I'm doing the math wrong. And I don't have a calculator near me, so there's the little one. Just checking, 180 minus 53 is 127. And then divided by 3 is 42. I apologize. 42. So the X equals 42.3 repeating. 42.3 repeating. Or 42 and a third. I probably would have also asked you to leave it as a fraction if I were to ask you that. Okay, next one. These two lines are parallel from these triangles. So we know these two should be equal to each other. So 4x plus 5 equals 6x minus 9. Minus 4x plus 9 plus 9, 2x equals 14 divided by 2 on both sides, x equals 7 here. This is just straight algebra. Oh, not this one though. So this one, these are parallel and these are parallel, so everything is following. So first let's get the x. So these are alternate interior angles are equal to each other. So 46 equals 2x. So that is, instead of 46, it is 23 equals x. So 23 equals x. And then y, 46 and y, since I know this thing is also 46, so then I could cover this part up. And then 46 and y are corresponding. They should be equal. So y is 46. Next page. We got some proofs on the next page, or almost on the next page. Next one, alternate interior angles. This goes to this one here, and this one goes to here. So alternate interior angles also equal each other. So 55 equals x plus 31. Subtract 31 on both sides. So that is going to be 4, 2. 24 equals x. Next one, these are perpendicular. So if they're perpendicular, you know this angle has to be a 90 in total. So these two angles are complementary. X plus 3x minus 6 equals 90. Combine like terms. 4x minus 6 equals 90. Plus 6 on both sides. 4x equals 96. Divided by 4 on both sides, x equals 24. So x equals 24 also. Okay. And then the next one. As I said in the last problem, these are perpendicular. So because they're perpendicular, they must be equal to each other. 75 plus x plus 8 equals 190? 90. So then combine like terms, that is 83 plus x equals 90. Subtract 83 on both sides, x equals 7. And then you can plug x into 7. 7 plus 8 is 15. 15 plus 75 is 90. All right, so let's prove that these are supplementary, 2 and 5. So how can we prove 2 and 5 are supplementary? We have to go piece by piece. Given that P and Q is parallel, so we have to point that out. P and Q are parallel, that's given. Then let's continue. I know there's multiple roots to this, so I'm going to do this. I know 1 and 2 are supplementary. 1 and 2 are supplementary. And I know that because they're linear pairs, so I know the linear pair postulate. Pair postulate. If I were to give a multiple choice question, it would say linear pair postulate, not definition of linear pair. All right. I also know 2 and 5 are congruent. So angle 2 is congruent to angle 5. I know that because or not angle 2. Angle 1, I apologize, is congruent to angle 5. Angle 1 being up here. Because angle 1 and angle 5 are corresponding angles. So that's corresponding angle postulate. The corresponding one is postulate, the other ones are theorems. So that's 1 and 5 being congruent to each other. Now I know these are congruent to each other. I can replace the 1 with a 5. So 5 and 2 are supplementary. And I know that, and I'm allowed to do that, I should say, because this is substitution. So substitution property. So that's a substitution property. All right, let's go to the next one. So chapter 4, which is, classified triangles. All right, so this one, if it was a multiple choice, the choices would be like a parenthesis, so equilateral and equiangular. Some people said acute, technically is acute, but equiangular is the more correct answer. So equilateral, equiangular. Over here on the right is the right triangle. 90 degrees, 35, 55. Since 90 degrees is here, this is a right triangle. And since none of the angles match, it's a scalene triangle. Scalene triangles are triangles that don't have any matching sides. If you were to randomly draw 3 lines and then, or 3 points and then connect the dots into a triangle, they would be more likely scaling than anything else. So let's continue. So this angle right here is 5x plus 20. This is 7x plus 15, and this is 16x plus 11. So what you can do is, since you know these 2 angles here should also equal the opposite angle here. So 16x plus 11 equals 5x plus 20 plus 7x plus 15. So we could combine all the like terms. 16x plus 11 equals 12x plus 35. Again, I move the smaller x over, so minus 12x, minus 12x. Move the whatever's left over, minus 11, minus 11. So I have 4x equals 24 divided by 4, x equals 6. So x equals 6 in this one. Plug it in and you'll check and it'll solve. Over here, all my triangles always add up to 180, all the angles of the triangle, I should say. So 25 plus 8x plus 2x plus 5 equals 180. Combine like terms, 10x plus 30 equals 180. Subtract 30 on both sides. 10x equals 150 divided by 10 on both sides. X equals 15. So x equals 15 in this one. Let's keep going. Oh, this diagram, these 2 statements are congruent. Notice that Q and X are in the same place. So Q matches with X. R, and I'll put a double underline, matches with matches with Y, I'm sorry. So over here. And S, triple underline, matches with Z, triple underline. Sorry, Z's a little cut off. Okay? So angle R is going to match angle Y, but we don't know what this is. But we know Q and X matches, and we know Z and S matches. So what we're going to do is set S to 50 degrees, because I know Z and S match. So 55 plus 50 minus 180. So 180 minus 55 plus 50. So I should do it like that. So the sum of this equals what angle R is. Or another way to write this, and probably more efficient or more straightforward, 55 plus 50 plus x equals 180. 55 plus 50 is 105. So 180 minus 105 equals 75. So this one's 75 degrees. 75 degrees. XY, so line XY. So line XY, since XY is the first two letters here, it has to match QR. QR we know is 6, so this is also 6. Angle X, we know angle X matches with angle Q. So if this was 55, this should also be 55. And angle S, we kind of found it along the way, matches with angle Z, so that should be 50. Okay, I think that was the last question of that test. All right, we're almost done already, and only 36 minutes in. All right, two triangles here. We have a couple of statements. Just remember what they are. Side, 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 angle, side, angle, side, angle, 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 side, and then HL. What is not allowed is SSA. You should know because if you spell it backwards, it's a bad word. And the AAA. You don't drive, so you don't have to worry about AAA. Okay, so you know this side is matching each other. So it's angle, side, angle. The side is in between the two angles, so you represent that in the letters. Angle, side, angle. The side touches both angles, so this angle, side, angle for that one. This one, this angle matches this angle. They're reflexive, so that's side, side, side. Over here, these are vertical angles, so vertical angles are congruent. And again, the side is in between the two angles, so it's angle, side, angle again. Next set. You see a right angle, you might jump to HL, but look at this. There's vertical angles here. Because of vertical angles, it's angle, side, angle. Angle, side, angle. Two angles and a side in between. A lot of angle, side, angles here. Oh, this one's a slight inverse, though. Two sides and the vertical angles match. So that's side, angle, side. So you know at that point they're equal to each other or congruent to each other. This side is matching to the two triangles, so that's side, side, side. Next one, number 7. This tripped up a lot of people. Left one is side, angle, side. The right one is angle, side, side. Or even side, side, angle, doesn't matter. Notice that these two are two different things. Side, angle, side, and side, side, angle. So these don't even match in that sense. So because they don't even match like that, that's not congruent. So this one's not congruent. Over here, we have the middle part right here. So that's going to be side, side, angle. Side, side, angle is not an answer. But because this is a right angle, we have a hypotenuse, we have a leg, so that's HL, hypotenuse leg. Over here, we know this side matches, but now look at it. It's side, side, angle, because the angle is not in between the two sides for, let's say, the bottom triangle. It's not between the two sides. So it's side, side, angle. Side, side, angle is not one of our things, so it's not congruent. All right, these proofs. Okay, so these proofs were a little bit busy for some people. Some people just forgot to write everything that's necessary. Well, some people didn't know what to do. So why don't we go over it? First, let's give the givens. I'm going to put it in one line to save time. So AD bisects CAB. And I'm putting in the same line. AC is congruent to AB. So that's a given. Okay, what's beneficial about that? AC, so this line over here, is congruent to AB, which is this line over here, okay? Let's continue. We said in the beginning, AD bisects CAB, angle CAB. So because of that, we know it bisects. We know this gets cut in half and this gets cut in half. So angle CAB, CAB. So yeah. So what we could say is angle CAD, which is this angle right here, is congruent to angle DAB, which is the right angle on the top. So it's congruent to DAB. DAB. And then this is because of definition. I know the word of bisector. Not midpoint, as many people said. This is not a midpoint. This is actually wrong if you say it's a definition of midpoint, because this is the angle of it, not the midpoint. All right, so next one. We have, let's see, we found a side. And we know these two sides are equal to each other. We know these two sides are equal to each other. Because it's equal to each other, we are going to set AD is congruent to AD for the easiest reason why, because it's reflexive. After that, we have our triangle, tick mark here. Maybe I'll put double tick mark here. Tick mark here, angle here, tick mark here. Sides with the angle touching both sides. So we have to give the reason that matches that. Side, angle, side. And that is the proof statement, which is angle A or triangle ADC is congruent to triangle ADB. So that's that proof. Again, the proofs are not on the test, but it's good to know the reasons because those will be asked in their own way. Let's go to the next one. This bow tie looking guy. So, line JK bisects line HL. Also, angle H is congruent to angle L. So, let's continue. JK bisects, and that's given. JK bisects HL. I'm bisecting HL, and if you had the period 4 test, it was reversed. So don't get upset if you look at your testing. This is different. But HL is being bisected. So since HL is being bisected, this piece right here equals this piece right here. HL is the one that's getting cut in half. So you have to think of it like that. So because of that, line HL is congruent to line LM. And that's because definition bisector. Next one. We could tell that these two angles are equal, but we can't just say angle M is equal to angle M because of vertical. Oh, and I should point out that angle H is angle L because they gave us that. So angle M and angle M, but when I say angle M, I don't know if you're talking about the top one, the bottom one, the left one, or the right one. So I got to be a little bit specific. JMH, so angle JMH is congruent to angle LMK. Angle LMK. So those two are congruent to each other. And what makes them congruent to each other? Because we know vertical angles. I think that was a vertical angle congruence theorem. So vertical angle congruence theorem. Now, if you just wrote definition of vertical angles or you just wrote vertical angles, I gave you credit. If it was a multiple choice, it's going to be the full line over here. Okay, so we have an angle, we have a side, and we have an angle. Let me show. We have an angle, a side, and an angle, and the side touches to both angles. So we should do angle, side, angle, because the side touches both angles. And that means that triangle HMJ is congruent to triangle LMK. Okay? But here's my problem. The proof statement wasn't that. The proof to JH, this line, is congruent to LK. Well, I just proved the whole triangle is congruent. Since the whole triangle is congruent, then I know from line JH is going to also be congruent to line LK. And these two are definitely going to be congruent for one reason. It's because we know all corresponding parts of congruent triangles must be congruent. So that's CP, CT, C. All right, this one, some people forgot how to do this. This is the mid-segment. You could tell because these two are equal and these two are equal. Since this is the mid-segment, QR particularly is the mid-segment, we're going to have to double the mid-segment. So 2x minus 3 equals x plus 9. So that's 4x minus 3 equals x plus 9. Again, I move the smallest x over always. Minus x plus 3 plus 3. 3x equals 12 divided by 3, x equals 4. So that's our first 4. Oh, I forgot something. And I made a mistake that a lot of people made. when you distribute the 2, you don't distribute it just to the 2x. You got to distribute also to the 3. So let me fix that right now. And that's what happens when you rush or when you do 5 tests in a row or 4 tests in a row. So you got to distribute to both. So that's 4x minus 6 equals x plus 9 plus 6 plus 6 minus x, 3x equals 15. Divided by 3, x equals 5. So x equals actually 5, not 6. And let's go to the next one. We're going to multiply this one by 2 also. So 2x plus 2, because this is in the middle, or inside the triangle, you can think of it like that, equals 3x minus 8. 2x plus 4 equals 3x minus 8. Move the smallest x over, minus 2x, and I did distribute, plus 8, I have 12 equals x. So x equals 12. Funny enough, if you don't multiply both of them, the answers are inverse. That is just random. That's literally just random. There's no reason why it does that naturally. Okay, this one. So since we know these line segments are equal, and we know this is the right angle, so this must be also equal, right angle. Since we know these angles are equal and we know these lines are equal, we know the base angle theorem says that these two are equal. So we just set them equal to each other. 3x plus 9 equals 7x minus 17, minus 3x plus 17. That's going to be 20, what am I doing? 26 equals 10x plus 7 minus 3x. Oh, I'm subtracting 3x. I'm sorry. So minus 3x. So that's 4x. Divided by 4 on both sides. That should be 6.5 equals x. And the other one, 6.5 equals x. Let me just check. 26 divided by 4. Yeah, 6.5. And then this one, because we see these two right angles and we see these two lines are equal, so we know they're equal to each other. So now we know 3a plus 20 equals 2a plus 26. Move the 2a over. Move the minus 20 over. It's 26. So that's a equals 6. Okay? We're almost done. Actually, yeah, we're literally on the last page. Last one. Since you know these marks are equal, you know these angles are equal, that means these two lines are equal. 10x minus 4 equals 4x plus 14. 6x equals plus 4 on both sides, 18. X equals 3. Not a lot of people got that wrong, thankfully. And then this one over here, some people just forget. So I said in the instructions, it's an in-center. So an in-center means that's where all the angle bisectors, is it all angle bisectors? Yeah, all angle bisectors intersect each other. So they all cut the angle. Now, this intersection doesn't mean all these angle bisectors are equal, but we know that all the right angled things are equal. So we know WT should be equal to ST, which will equal UT. Since WT is 15, we know ST is also 15. So the answer for this part here is 15. Well, my pencil just broke on the last question. So that's kind of a sign of it's all over. I hope this video helps. I hope you guys actually watch it. If you're someone from another class, I hope this also helps. Otherwise, take your time to study. Wednesday and Thursday and Friday. For geometry, I won't be here Thursday. So Wednesday and Friday, I'll be here for review. Please bring particular questions. Do not simply ask, oh, can you teach me everything, Mr. Tobel? I'm not going to help you with that. I literally did a video on everything. Otherwise, I wish you guys good luck, and I hope you do well on your midterm. Don't stress out. I know you guys are prepared, and you guys will do well. Have a wonderful day.